Okay. Thank you everyone for coming for today's seminar. We have Tim DiLauro from the Digital Knowledge Center here on campus. He's going to give us an overview of digital libraries. Thank you.
As Bill said, I'm Tim DiLauro. I'm from the Digital Knowledge Center, which is in the Sheridan Libraries here on the Homewood campus. And it's a pleasure to be here today. I want to thank Bill Byrne for inviting me to come and talk. One of the things that's great about being able to do this is I saw Bill today, right before this talk began, and I think the last time I saw Bill was at another meeting, but I never see Bill on campus. So even though we're very close to each other, we hardly ever talk to each other. So this is a good opportunity for me to tell you a little bit about the DKC and what we're about in the context of digital libraries. I'm going to give you a general overview without a lot of technical detail, at least not as much technical detail as you're probably used to from other speakers in this seminar series. An overview of my presentation. I'm going to give a definition of digital libraries, one that I like, a little schematic of a system architecture. Then I'm going to talk a little bit about the Digital Knowledge Center. And I'm going to talk specifically about ingestion and access projects that we have in the Digital Knowledge Center. These projects sort of represent two ends of the spectrum, the types of projects that we do. We have digital libraries sort of deal with the approach that computer scientists come at it with, which is we can build this thing and you just put stuff in it. And the approach that libraries bring to digital libraries, which is more oriented toward an extension of the physical collections. And then at the end, I'll talk about some issues, research issues for digital libraries. First, the definition. Digital libraries are organizations that provide the resources, including the specialized staff, to select, structure, offer intellectual access to, interpret, distribute, preserve the integrity of, and ensure the persistence over time of collections of digital works so that they are readily and economically available for use by a defined community or set of communities. This comment was made by Don Waters several years ago when he was the director of the Digital Library Federation. He's now a program officer at the Mellon Foundation. And this, I think, is a nice schematic of what a system architecture might look like at a very high level for a digital library. As you go up in the schematic, you move from the highly granular data elements of a digital library, which really are just bits. They don't have any real context. You move up to making data into information by adding semantics, schemas for the data, something that contextualizes the data, and knowledge by relating concepts together. And as you move from left to right, you have a process of bringing material into digital libraries. The ingestion process brings the material in. The management process keeps track of the information, makes sure that the information hasn't become stale, and the access component delivers the information to the end users. Now I'll tell you a little bit about us, the Digital Knowledge Center. The Digital Knowledge Center is the research and development unit of the Sheridan Libraries. Our overarching goal is to ensure the proper ingestion of print materials, materials that were created non-digitally, into the digital library environment, and we call that ingestion. Our work focuses on the creation of tools, processes, and systems that combine automated and manual techniques. Our goal is not to to try to do everything with a computer, and our goal is not to try to do everything with a librarian. We want to take the things that a computer can do very well and let a computer do those things, and then focus the human labor on the tasks that computers aren't able to do very well right now. To help maximize our ability to deliver useful and usable systems, we have a usability specialist. I like that term, guarantee, helps guarantee. Well, we try our best to create systems that are useful and usable for our end users, who are in our library, the patrons and other end users at the end of the web. And collaborations and partnerships are a significant component of the Digital Knowledge Center's work. We have collaborations within the library, especially in our special collections department and our cataloging department, and partnerships within the university. Some of those partnerships are with people in computer science who help us by getting us in front of people like you, or getting us in front of lecturers and able to talk to students, or giving students projects that are digital knowledge center projects, and sometimes giving them credit for it. And then we have some external partnerships as well. We have some partnerships, Tufts University, the University of Edinburgh, the University of Oxford, British Library. And now I'm going to talk a little bit about our ingestion projects. I'll start with an overview of the projects, and then I'll briefly describe each one of these. I'm acutely aware that it's late in the afternoon, and I don't want to bore you to death at this time of the day. So I'll try to give just brief descriptions of them, but hopefully rich enough that you can understand what we're trying to do, and maybe you might find places where you have interest in these projects. I'll start with GAMRA, which is a framework for developing document analysis and recognition systems. Then I'll talk about automated metadata, ANAC, which is an automated name authority control tool, and SCALE, which is an evolution of ANAC and some work from Tufts University that your colleague David Smith there is intimately familiar with, to provide a system for customizable authority lists and reading support. Then I'll talk about Flexus, which is an indexing environment and search engine. The CAPM Robotics project, which is usually of great interest to people. It's often called the robotic librarian. I hope that you won't call it that, because we get in a lot of trouble with our librarians. They think we're trying to replace them. And the last project that I'll talk about on the ingestion side is the Peabody Digital Audio Archives project, which is actually our first foray into the non-text world. So I'll start with GAMRA. GAMRA stands for Generalized Algorithms and Methods for the Enhancement and Reconstruction of Archives. But the name GAMRA actually came from a Godzilla monster that looks like a big giant flying turtle with rockets on its back, and we came up with that first, and then we tried to find some words that would fit into it that actually matched the context of what GAMRA is doing. GAMRA is, as I said, a document analysis and recognition framework. It has some image processing tools, filters and binarization for dealing with the raw image initially, symbol recognition in the form of features and classifiers. I'll talk a little bit more about them in the next slide. And then syntactical and semantic analysis to actually capture some of the meaning of the document instead of just the symbols that are on the page. Some of the features of GAMRA is it's extensible. It's created with Python and C++, and Python is wrapped around the C++, so there's not need for the end users of the system to be C++ programmers. It has a graphical user interface, and the graphical user interface is useful for developing classifiers, training classifiers for creating batchable scripts. So when you sit in the user interface, whenever you deal with an object, information about that transaction is stored in the interface. So you can actually capture each one of the commands that are executed by using the graphical tools and place them into a script. So it's interactive and batchable. In the case of our Levy sheet music collection, which we did a lot of this initial work for, we have 30,000 items, which is not a huge number of items. It's about 130,000 pages. We certainly wouldn't want to sit in an interactive environment and process all those pages. So the scripts can be captured from that interface, parameterized in some way, and then used to process many, many documents. The system is easy to use. We use... Yes?
You said this is a music collection?
Music collection is something that we were working with, but it's a general symbol recognition system.
Well,
so it can recognize musical...
These are notes?
Say that again?
These are notes? I mean,
there might be notes on a page, there might be text on a page.
And how would you process those?
You process them by initially capturing the symbols on the page and deconstructing them, and then using the semantic tools that are created for each context. So for music, there would be a different set of semantic tools for taking the symbols, finding their relationships with each other, and then capturing the semantic information from the music.
So you might want to find all C# minor keys or something like that.
Well, we don't want to do that with Gamera. We want to find them and recognize them and create a document from the image. And then somebody else may want to search them.
When you said classify,
Yes.
you mean what?
Based on the features that we use for music are features like the aspect ratio, how much black there is in a space. First we segment into contiguous symbols. So
Classify based on some properties of the image.
On the set of features for a symbol, for an individual symbol. In the semantic component is when we put the symbols back together, find their relationships with each other, so that we understand what the symbol actually means. In the case of music, for example, you have a clef, you have staff lines. You have to know what clef you're reading. You have to know where the position of the staff lines. You have to know what your key signature is. You have to know what your time signature is before you can decide that this note has half note duration. It's an A, and because of an accidental, it's an A sharp. And you also need to know its position within the composition as well. So that would be work that's done by a semantic processor for music. We call that process optical music interpretation, and that happens after symbol recognition. We do the same thing for text, semantics for text.
So given an image, you're going to classify it.
We're not classifying the document. We're classifying the symbol.
Yeah, the little image with symbol.
Right, exactly.
And you're going to say whether that's a clef or a staff,
right,
or a sharp, or a flat.
That's right. So the system has to be easy to use for the people who understand the documents that they're working with. We call them domain experts. So that's why we actually use Python wrapped around C++, so that the people who are doing this work, they might be experts in their document area, but they're probably not C++ programmers. So we wanted to create a simple environment for them to be able to do this work. And finally, it's portable. Linux and Windows support now, and Mac OS, OS 10 support. Hopefully coming soon. We just have a problem with one of the libraries. So we'd like to make it available on a wide variety of platforms. Automated name authority control. I told you about Gamera and how clever we were with our Godzilla monster. Well, automated name authority control is one of those examples where we didn't really do such a clever job with the acronym. So if anybody has a clever acronym that describes this process, we'd be glad to hear it. The purpose of name authority control is to allow you to match variant forms of a name with an individual. And the reason this is important, I'll give an example case. Mark Twain and Samuel Clemens are the same person, but they are two different names. If you were searching in a library catalog and you search for Mark Twain, you would probably want to find the information about Samuel Clemens. In the case of our music collection, I know you like the music stuff, we have, in our collection, we have a fellow named Septimus Winter. And he had many pseudonyms. One of the pseudonyms he used was Alice Hawthorne. And there are many pieces that actually say, composed by Septimus Winter, lyrics by Alice Hawthorne. So if you were to look at this piece and see that without some form of authority control, you would assume that there were two different people who worked on this. And it might be important to have that context, that it was the same person who wrote the lyrics. But it's certainly important to understand who it was so that you can find other works by that person. The way this system works currently against the Library of Congress authority file, but we plan to generalize it in this project called Scale that I'll talk about in just a minute. Some of the features that we use for matching names from the music to the LC authority list are consistency or match of title, that is Mr., Mrs., and so on, first name, middle name, last name. So a consistent name might be J.P. Souza and John Philip Souza would be a consistent name match. A suffix like Esquire, a date of birth versus the publication date. These things are done with probability, so we don't say that if the person is born after the date of publication, it's a sure thing that they didn't publish it. But it's very unlikely. It's very unlikely that somebody published a work before they were born. But there are some possibilities. Somebody made a mistake when they keyed in the record at the Library of Congress, or somebody made a mistake when they keyed in the record for the sheet music. And information from the LC authority file note field. If, in the case of music, if the note field contains some information that's related to music, then we increase the probability of a match. And finally, we capture the authorized form of a name. And we can do that by either capturing the form that the Library of Congress uses in their main entries, which is the person's name, comma, year of birth, dash year of death if available, or we can capture it by just storing a control number that identifies the LC authority record. As I mentioned, that project, yes?
Is there a schema in the Library of Congress authority file for dealing with multiple names of the same virtue?
Not really. There is other information that can be added to the authority record in those cases, but in the main entry, no, there's not.
Does the Library of Congress file have variant spellings for given, like foreign names like Gaddafi might be spelled
Yes.
differently in different newspapers, G or it has that as well?
Yes, the LC authority file does have information like that. It probably doesn't have every possible spelling. I remember seeing a long time ago on Saturday Night Live something about how do you spell Gaddafi, and it had about 600 ways you could possibly spell Gaddafi. But it does have lots of variations. And it also has variant forms for different languages for transposition, or transliteration as well. But as we move into the scale environment, we're not necessarily going to be using the LC authority file. We want to be able to use it, but we want to generalize what we think of as an authority list as opposed to the authority file. And we want to move away from the term authority control, because the term authority control has a lot of library baggage attached to it, and you start to get into semantic arguments with people about it. It's like hidden Markov models. People standing up and saying, no, that's not a hidden Markov model. So we don't want to get into that. So we're moving away from that term authority control. So we want to deal with authority lists. This is a collaborative project. Tufts Digital Collections and Archives submitted a proposal. We submitted a proposal and joined them together. And we're building on, again, a lot of work that David Smith there did in the Perseus project, and the work that we're doing with the ANAC project. Again, if somebody can think of a better acronym for it, please do. Okay, now I'm going to talk about Flexus. Flexus is a indexing environment and search engine that was developed by two computer science students who worked in the DKC under the supervision of David Urowski. And the idea behind this system was to create something very flexible that could be used in a lot of different ways, but had the same core engine. You didn't have to change the core engine. You could just change the front end to it. In that way, it's very similar to Gamera in that you don't have to have a lot of expertise in using search engines or developing search engines to do new and clever things. As somebody who's not an expert. The way Flexus works is it starts with input tokenizers. The input tokenizers can do just about anything to a data stream. And all they have to do at the end of their process is put a single token separated by a carriage return on each line. That's fed into the indexing engine, and a basic inverted file index is created. And then the really good stuff happens. Secondary indexes. Secondary indexes allow a mapping from one term to multiple terms in the primary index, that inverted index there. So you can start to do clever things like, for your input tokenizer, you might run a corpus through a part of speech tagger and create tuples of word/part of speech. So that would be a token. And then from that token, you can separate those two pieces out. And in your secondary index, you can create an index that has maybe lemmas, or maybe sound-X terms, or maybe a list of matching thesaurus terms. So I'll give a real example so this isn't so abstract. If you have words part of speech tagged, for example, you could do a search. You could create a secondary index that points from the base form of a verb to all the other verb forms, the lemmas, the lemma forms of that particular verb. So if you had fly, you could map to fly as a verb, flown as a verb, flew as a verb, flying as a verb. So now you can start to do things like searching for lemmas and not using things like stemming, which will break for flown or torn and things like that. Another interesting feature is partitions, and partitions basically are a way of representing disjoint regions within the document. They generalize very well to XML, XML tags, or XML containers. And partitions allow you to search within a particular area of a document and perhaps return the entire document or return information from another area of the document. And finally, parallel indexes. There's David. Parallel indexes allow a mapping between two corpuses. So in the primary corpus, you can map from one position in the primary corpus to multiple positions within a secondary corpus. And by doing that, you might be able to do some cross-language searching if you have corpuses that are aligned properly. The Kaplan project was one of the very first projects in the DKC. In fact, I think it may have even started before the DKC began. Kaplan stands for Comprehensive Access to Printed Materials, and it was really a response to the Moravia Park situation. I'm not sure how many of you know about Moravia Park. It's where the library stores materials that don't fit in the library anymore. One of the concerns as material moved out to Moravia Park was how fast the material could be retrieved and how people would browse the material since they didn't have access to it anymore. Kaplan was a response to that. And the second bullet there is the goal of Kaplan is to develop efficient, real-time enhanced browsing and search capabilities through the internet to offsite materials by using a combination of robotics, automated systems, software, and high-speed telecommunications. So far, a prototype robot has been developed. This is the infamous robotic librarian that causes so much stress in my department. And the robot actually does work. It hasn't been tested at the facility per se, but it's been tested in simulation of the Moravia Park facility. We think it's designed in such a way that it could work in a variety of facilities. Now there was something else I was going to tell you about that. Well, so now we need to, the work that needs to be done now is to incorporate a page turning system, because right now the robot can fetch the material and bring it back to what would be a scanning station, but there is no scanning station available right now for page turning and scanning. We have an ITR grant that we wanted to do that work within, but that grant was cut down a little bit, so we won't have the money to do the work. The work that has been done so far in Kaplan has been done in the mechanical engineering department here in Greg Cherichian's lab. And the last project I'll talk about on the ingestion side is our first foray into non-textual documents. And that is the Peabody Digital Audio Archives, really more specifically into audio or video. This is our first foray. The idea here is to develop a system for digitizing audio from Peabody performances. We want to be able to, without too much work, without somebody having to, an individual, a person, having to go through the actual recordings from end to end, we want to develop a system to do audio segmentation so that we can find the ends of pieces and the ends of movements within pieces. We want to do this in a way that's generalizable to other genres of music. The information that is captured from the Peabody tapes will be integrated with information from concert programs. Those will be scanned by the people who are operating the reel-to-reel tape recorders. And it has an intellectual property, copyright, digital rights management component, and this is our first real foray into that environment as well. Something I should mention about the PDAP Kaplan project and Flexus is that I have these projects listed as ingestion side projects, but they really go from ingestion through access. But they started ingestion, so I decided to put them there. I'm going to talk about our access projects, and I'll try to get through this fairly quickly. I'll talk about our access projects now, and I won't go into quite as much detail. I'll start with just what our access projects are about. The access projects, unlike the ingestion projects, are really focused on users' needs, their styles of using materials, and their preferences. Usability testing, which is done by our usability person on staff, sometimes in conjunction with other people, depending on the project. It provides an objective, rational feedback mechanism, which is kind of our response to what happens sometimes in the library, which is, well, you know, people need this, and well, people really want this. They really want to do this, but without anything to really back it up. A good example of that is when we introduced our new library catalog several years ago. We had a facility that on the web page was described as patron empowerment. When we finally got around to doing some usability testing on this thing that was called patron empowerment, we asked the patron to find their borrower record so they could find out information about what they had checked out, if they had any things that were recalled or should be placed on hold. And they couldn't find it because it was called patron empowerment. And they had no idea what that meant. That was the vendor's term for the facility. So we learned something very important that day. And we know now that usability is very important for the work that we're doing. Usability research, as distinct from the usability testing, is research on the methods of testing themselves. So we can find out what testing mechanisms are appropriate in our environment. A lot of the usability work that's being done in digital libraries right now has been co-opted from the commercial world. So we have to wonder whether metrics and mechanisms that are useful for e-commerce sites are really useful for digital libraries. For example, on an e-commerce site, the developers want to make sure that the person gets to what they're looking for quickly and efficiently so they don't become angry or enraged and leave, go to another site and buy their product elsewhere. But in a library, it's very different. We want to facilitate browsing. We want people to have the ability to have serendipitous discovery, just as they do when they're wandering the stacks. So the mechanisms have to be different. So that's the focus of the usability research. And finally, costs and benefits from a real economic evaluation perspective. We have decided to adapt techniques used in the environmental world because they are much more similar to the library world. There's a lack of defined market. People don't understand what the cost of materials are because they're not buying these materials, they're just using them. So the techniques are more hypothetical. What would you be willing to pay for this? Which would you prefer, this or this? And those techniques are being applied by, we have one person with an economics background in our department, and he's doing work in that area. And finally, I just wanted to talk about, or just briefly mention actually, some of the areas that I think are of tremendous interest in the digital library research world right now. Probably the hottest topic is building repositories. The National Science Digital Library is up there, but it's probably not the hottest topic right now. This concept of institutional repositories that some of you may have heard about, embodied by DSpace and Fedora. DSpace is designed to provide an end-to-end solution. And so starting from the ingestion process, management of the content, being able to build collections from the content, and delivering the content as it was ingested to the end user. Fedora provides a different mechanism which still allows the storage of the content, but puts behavior mechanisms between the end user and the content. So objects of different types can be made to behave similarly. For example, a book and a journal could be made to look similar in some ways. Books and journals both can have tables of content. They both need a mechanism for going to the next page. They both have a front cover and a back. So you can make those two objects look kind of similar, and they only need to diverge in moving from chapter to chapter in a book, perhaps, and article to article in a journal. Non-textual materials is an interesting area, mainly because I think it's so difficult. I know there's some experience here with the Malak project, and probably some others as well, which is dealing with some very complex speech issues, emotional speech, multilingual speech in the same stream. The Infomedia project is dealing mostly with news, broadcast news, and they still have a tremendous amount of trouble processing the data. I've seen some demos that they've done that were canned and because they couldn't get them to work quite properly. I forgot who I saw from the National Gallery of the Spoken Word, but they put forward a very interesting idea for us. We're always trying to get as accurate as we can with the information that we're extracting. But they were talking about what level of accuracy do you need to be able to build a reasonable retrieval system. I think that's a very interesting idea. I don't know if Malak is doing that as well, but it's a very interesting idea. Underrepresented materials are a big issue for us. I think that there's going to be a big bang for the buck for humanities and cultural heritage materials because it's going to fundamentally change the way work is done in those arenas, or at least it has the potential to change because there is so little data in those areas right now. The material is older, it's often in printed form or some artifact form. It's not easily ingestible, and it's not being updated periodically, so the new copies aren't being created in a digital format. So those materials, somebody actually has to make an effort.
Example of an underrepresented material.
An underrepresented material, cuneiform tablets, decoded cuneiform tablets, humanities texts in general.
What do you mean, like some ancient Bible?
An ancient Bible, old history books, all sorts.
You can scan.
You can scan these things, but they're not being created in a digital format. Old Greek texts, they're not being created in a digital format, so somebody actually has to take these materials, send them off to get them keyed. So
scanning is not good enough because that's facsimile and you can't...
Scanning is good enough, can be good enough, but all these things cost money. My last bullet there is financial models, and I'll talk about that in a minute. But somebody has to pay for those collections to be brought in. So if they're old materials, and there's not a business case to bring...
You only need one in the whole world, right?
One? Well,
yeah,
that's
once you scan it in, now we can transport it everywhere.
One of each item.
Yeah, that's what I mean.
Yes.
So you don't have to
perhaps
take care
you
of it, and you don't have to have a sub-zero temperature in it and pressure and whatever.
Well, no, that's not true. The scholars want access to those materials.
To the origin.
To the original
so we still
materials
have to take
in some cases. So we do have to take care of them. And there are cases where even when you have the same basic document, there's a document that we're working with called the Roman de la Rose, which is a medieval French text that has been transcribed many times, and we have many different copies of it, and depending on who commissioned the work will be different. The work will have different embellishments. So chunks of text will be left out. scholars are interested in finding when the scribal hand changes. So just because of the title, it's the same title or the same basic work. No, it's not necessarily enough to just have one copy. And there, even if you can scan the document, you can't, in many cases, you can't recognize the text of the document so that you can do good searching across a large corpus of these documents. So that's part of the problem. Some of these things are script. There's a lot of work being done in handwriting, but the results are not tremendously good. And degraded documents, I have humanities collections, cultural heritage collections, which might be some of these other forms that are artifacts. And degraded documents that are in such bad shape that we have trouble processing them. We've been actually fortunate. We've made a contact with a fellow by the name of Henry Baird, who's at the Statistical Pattern and Image Analysis Group at Park, who is interested in our Gamera work and has decided to free up some of his code to allow us to plug that in. And he's got, they've done some work on degraded document modeling. So we're going to be very interested in trying that out within Gamera. Also, for information from them, we have the system that we have in Gamera right now really works in a pipeline. So we have local optimizations at each step where we're doing the symbol recognition and then doing the semantic analysis. We don't have language models in Gamera, and we don't have a global optimization mechanism in Gamera either. So we're going to be trying to do something in that area as well. The last really big hot topic is digital preservation. There are two big projects. One is really huge, the National Digital Information Infrastructure Preservation Project, which is really even a more horrible acronym than our ANAC. I'm hoping that they'll come up with something new and better for that. The goal there is to start to capture all this digital information that's being produced, like the Library of Congress captures books that are produced. And the LOCKSS project, which stands for Lots of Copies, Keep Stuff Safe, which is a much better acronym. The goal of that project is to develop a mechanism for capturing publisher information, journal information for electronic journals, so that if a publisher suddenly disappears, the content doesn't disappear with them. And this is a response to having print subscriptions, having to acquire print subscriptions in the digital environment. If you can have a mechanism like this that has lots of these caches that check each other, vote about problem resolution when a bit gets flipped and so forth, you have a much safer environment. And the last thing I want to mention is financial models for sustainability. Basically, it sort of answers your question about can't you just scan this material? Funding agencies have been and are continuing to reduce the amount of funding that's available for digitization projects, collection building projects. So some mechanism has to be developed, or mechanisms have to be developed for integrating the acquisition of digital content, whether it be from digital sources or from print sources being digitized, into digital libraries. And that is the end of my talk. David.
Yeah, I think for a lot of people working in the sciences, the library is sort of solved the problem. We go online and read journal articles and conference proceedings, either self-posted and archived or in subscriptions that the library buys us at great cost, but we don't know about because we belong to this nice research university. What might be, when you're talking about new frontiers in digital libraries, one thing that I didn't see mentioned was data sets. For example, in our case, linguistically annotated corpora, or things in the genre of the Penn Tree Bank, but on a larger scale, or initiatives that some universities have to get researchers to deposit their psychological raw data sets with the university archives. Is there anything along those lines doing at the library here?
We're not doing much in that area, but I'll go back up to that system architecture. There is a lot of work being done and interest in this area. It's just that we're not doing it in the Digital Knowledge Center. And I think there are people who can do it a lot better than me. So it's not one of those things that I'm focusing on very heavily. But if there is interest in this group or in other groups around the campus that are things that are related to digital libraries that you think might be useful in the DKC, we're always interested to hear those ideas and to see if we can accommodate some work. Sometimes we have people come in and just do some work for credit, or sometimes for money even, and take that work and roll it into something that we're working on. So we try to find a match between what we're doing and what you're interested in, but sometimes there's a compelling case that will get us going in a different direction.
So what do we envisage for the future? I mean, in ordinary books, I mean, do we envisage that every book will be in machine-readable form, and when I want to read it, I will print it out? Oh, I mean, I certainly don't want to read it off some screen. I can't take it to the bathroom or nothing. I mean,
Get a laptop.
can't read it in the bus. So what are we going to, and how expensive would it be to do this?
I don't know how expensive it will be.
Very expensive, right?
I think some of the things that you're looking for are happening with new display technology. So as long as you can get that display in your bathroom, you can read the material there. Or maybe you can get it on your laptop with your wireless network and take it in and read it there. In terms of printing out, I think for a long time there's going to be a role for, a very long time, there's going to be a role for the printed book. A lot of people like that form factor, and they're going to continue reading that way.
I'm thinking of, right now we still have interlibrary loans, right? And,
Yes.
and I happened to have borrowed a book just yesterday, and it took 3 weeks to get to me. Now, of course, if I could get it right away, would be much better, because I get it and I look at it, and now it turns out I don't want it.
Right.
And now everybody went through this enormous effort to get it to me.
That's right. That's very much one of the ideas behind CAPM, the robotics project. It's to have that facility to bring the book from remote shelving to a scanning station, so you can sort of flip through the pages and see what you're getting. And so it's the idea that Amazon has now with a lot of their new books. The first 20 or so pages of the book is online, so you can sort of flip through it and you can see the front cover and the back cover to see if that's the material that you want.
But do you envisage, in fact, that everything would be in machine-readable form and accessed by every university and so far and so forth?
Not for a very long time.
Not
because
for a long.
Yes, because publishers have mechanisms for making their money. I think until some questions are answered in the area of digital rights management, there's a lot of antsiness on the part of publishers to make all their content available that way. We have had a few cases in the university environment where some materials were made available for courses.
Mm-hmm.
They were textbook material was made available for courses by the publisher, but it's very rare. Yes?
So I'm curious, why digital rights management hasn't developed faster.
Digital what management?
Digital rights management.
Rights.
Yeah, what Tim is talking about.
Yeah.
So when the net was first taken off, I thought it was going to be, sorry, when the web was first taken off, I thought it was going to be a matter of a couple of years before we got a micropayment architecture set up so that you would just pay by the article a few cents for anything you read online, or you had a subscription to some conglomerate, so that you paid $30 a year for unlimited reading or something like that. I don't understand why this stuff has been held up because the protocols have already been developed, as far as I understand.
And I think this architecture does exist for journal articles now. It's just not a few cents. It's $10, and it's not $30 a year for the service. It's $30,000. So is the question why is
well? So some things that are so micropayments is a separate area of research in cryptography and security, because you need to be able to do things which are you need to be able to pay a fraction of a cent without the overhead killing you.
Of course.
So $10 you might be able to get by with a different architecture.
Right.
That's which the publishers may not be using the micropayment architectures. Nonetheless,
there are multiple micropayment architectures. That's the beauty of standards, I guess, as everyone always says. There are so many of them. But there's a lot of greed and there's a lot of fear about content being digital and controlling access to content. I think there certainly has been in the past a sense in the library world of acting as gatekeepers for information as opposed to giving people direct access to information. I think there are some changes in that area, but those changes haven't gotten to the publishers yet. Their models are based on selling big subscriptions. They're not based on selling articles necessarily. They want to sell to universities. They want to sell the big ticket items. And their inflation is incredible, somewhere in the 25% area, something that massively outpacing inflation. So
why?
no one can tell you why. The journal,
I mean, a book.
The journal publishers, their prices just go up.
Yeah, but I mean, that can be just that they can get away with it.
That's exactly right.
Well,
you've hit the nail on the head.
So it's not their inflation, it's incredible. They create the inflation. I mean,
well, we create the inflation too because we have systems that sort of lean toward those big publishers. The systems of tenure review, for example. You know, if you have to decide whether you're going to publish in the free online journal or you're going to publish in the in Nature, you know, where are you going to publish? You're going to publish in Nature if you don't have tenure yet. Yes, if you can get accepted, exactly. So some of those ideas I think need to change as well at the level of authorship and at the university level. And I think that's in the area of financial models. Financial models need to be developed for self-publishing at multiple levels, preprints and in the actual publication, that have fair models for cost recovery, because it's not free to do free publishing.
So the university's already paying faculty members to write these articles.
That's right. The university is, but the university is,
and it's also paying the publishers for the articles.
Been paying the publisher for the article.
But you compose it on LaTeX, so they don't even have to do the composition.
Exactly.
They don't do anything.
Exactly.
Exactly.
Well, this is the argument that has been made.
The lazy model. Yes.
So all of us have been frustrated with this. In fact, in our particular field, we're very lucky because the ACL, for example, Association for Computational Linguistics, has very liberal copyright policy. And in fact, not only gives you the right to post your papers on the web, but there's an archive where all the papers are completely freely available. So we happen to be lucky. Nonetheless, the situation in science is dire from this point of view in general. It still doesn't answer my question entirely, though. So I understand that there are established interests, like the big journal publishers, for types of publication which have which have been around for a long time and around which institutions have been developed or entrenched. But I don't understand why Salon Magazine isn't using micropayments. So they've been looking for ways to, they've been looking for ways other than advertising to make money for quite a while, and they've settled on various kinds of subscription models. I don't understand why the New York Times is selling its archives at $2.50 an article, when I'm sure very few people are buying that. You know, there are people who will pay that much because they really need the article. But I think that there are lots of cases where people are looking for new business models, and charging $2.50 an article isn't going to work. Micropayments might work. Why aren't there parts of the web where these standards are emerging?
I'm not sure. I'm not sure. It's not one of the areas that we're looking into. Can't really give you a good answer.
It's not technological as far as I know.
As far as I know, no, it's not technological. A lot of the issues that we deal with in digital libraries are not technological in nature.
Okay, well, thank you very much. Jason.
Hi.